folks, welcome to 6.1, Verifying Trig Identities. We're going to do these videos in two parts to give you a little bit of chance to digest some new information and also refresh yourself on some old information. So this first part, we're going to do a refresher on a bunch of trig identities that you learned in your trig class. All right, so these are what I would consider the fundamental trig identities, and I would really encourage you to know them and love them. They do come up very frequently, not just in pre-calculus, but also in Calc 1, also in Calc 2, and I want to make sure that you feel confident on these as you move forward. Okay, so let's do some refreshers. These functions right here, these three, are ones that we would call the three main trig functions. So when you think about trig, a lot of us think sine and cosine and tangent, and that's exactly our three main trig functions. And then on the other side, these three, these are actually our three reciprocal trig functions. And so it's already right here that you know some of these reciprocal identities. So we can say that cosecant is actually 1 over sine theta, which means that sine theta is really 1 over cosecant theta. And cosine theta is 1 over secant theta, and secant theta is 1 over cosine theta. And cotangent theta is 1 over tangent theta, and tangent theta is 1 over cotangent theta. Now those are probably identities that we know so well that we don't even think they're identities, but that's exactly what they are. They are things that are always true anytime we talk about these trig functions. Two other ones that you might also know super well and just not realize that you know are that tangent and cotangent can be expressed as two different functions divided by each other. So we can actually say that tangent is sine theta divided by cosine theta. And if you think back to your trig class and you were trying to find tangent on the unit circle, you probably took the y values, which are the sine values, at an angle, and you divided it by the x values. Okay? Now that's a good reminder that sine is actually the y values and cosine are the x values on the unit circle. And we'll use that a little bit later on. Cotangent, because I know it's the reciprocal of tangent, I can just write it as cosine theta divided by sine theta. Or if I wanted to think about it on the unit circle, I could say that it's x values divided by y values. So here we have our reciprocal identities and our quotient identities. Let's move on to our even and odd identities. And we're going to start with even identities. And we're going to start with a definition of even identities. So anytime a function is even, you know that f of negative x equals f of x. And so if we think about which trig functions are even, we'll find that cosine and its reciprocal function secant are even functions. And if we apply that even definition, we'd find that cosine of negative theta equals cosine of theta, and that secant of negative theta equals secant of theta. we can use a similar process to help us find the odd identities. And the definition of an odd identity is that f of negative x equals negative f of x. And it turns out that the other 4 trig functions are all odd. And so we can say that sine of negative theta equals negative sine theta. We can say that cosecant negative theta gives you negative cosecant theta. We can say that tangent negative theta equals negative tangent theta, and that cotangent negative theta is negative cotangent theta. Now those proofs, the ones that we're going to use, the even odd ones, tend to be pretty clear. Anytime you see some sort of minus sign, you're probably using the odd even identities. Cofunction identities. So cofunction identities are maybe a little bit less intuitive than the other ones we've seen so far, but they really help us find out if we know one of the trig functions, can we find the other one? And so there are actually 3 pairs of cofunctions when we look at these 6 functions. The first pair is sine and its cofunction cosine. And so if we take sine of pi over 2 minus theta, we'll actually get cosine of theta. And if we take cosine of pi over 2 minus theta, we'll get sine theta. Now, as weird as this might look, let's imagine for a second that we were talking in degrees, not in radians. And so instead of pi over 2, maybe I call that 90. And let's pick an angle. Let's say I said that I was looking at a 20-degree angle. If I take my calculator and I plug in cosine of 20, and then I take my calculator and I do sine of 90 minus 20, I'll find out that those two are equal. And so maybe that's a more concrete way of us understanding the cofunction identity. Now, same thing, if I took cosine of, let's say, 90 minus 30, that should give me the same thing as if I type in the sine of 30. And it does. And that's actually how we came to call them sine and cosine, because they're cofunctions, and this very property is true. Now there's 2 other pairs of our cofunctions. So we've got this pair, our secant and cosecant. So cosecant of pi over 2 minus theta will give us secant of theta. And secant of pi over 2 minus theta will give me cosecant. And then our last cofunction pair are these 2 right down here. And tangent of, this should say pi over 2 minus theta. Tangent of pi over 2 minus theta will give us cotangent of theta. Then cotangent of pi over 2 minus theta will give us tangent of theta. And those are our 3 pairs of cofunction identities. And again, when we use these in proofs, it'll be pretty obvious because we'll have the pi over 2 minus something. That part will be there. Okay. Last part of this video is we're going to talk about the Pythagorean identities. Now, when we talk about the Pythagorean identities, there are actually 3 of these. And as you can tell from all the stuff we've already seen, there's a lot of stuff to memorize. And I don't know about you, but for me, sometimes I just can't memorize everything I need to. And so with the Pythagorean identities, I actually choose to memorize one of them, and then I know how to get from that one to the other 2. So really, I just have to memorize one. Okay? Try that strategy, see if it works for you, but let me just talk through my understanding of the Pythagorean identities. So if I asked you guys, what is the Pythagorean theorem? Everyone would tell me a squared plus b squared equals c squared, and you would be correct. And if we thought back to the unit circle in trig, and we thought about how we found the coordinates of all those points, we would remember that we used a right triangle. And that if we wanted to use the Pythagorean identity on this right triangle, we could say that x, which is this part, squared plus y squared equals, now the radius of a unit circle is always 1, so 1 squared. And in fact, we might just write that x squared plus y squared equals 1. And then, as I mentioned a few slides ago, I actually said that the x value on the unit circle was really cosine theta. So I can replace x with cosine theta, and I can replace y with sine theta. And I'll get something that looks like that. Now, mathematicians don't like to write extra things if they don't have to, so in this case I would consider the parentheses to be extra. And so instead of writing cosine theta squared, they actually write it like this, cosine squared theta. And we would do the same thing for the sine, so we would get sine squared theta equals 1. And this is the Pythagorean identity that I choose to memorize. And I'm going to show you how we go from this one to the other two. And so what we're going to do here is first we're going to divide by cosine squared theta. And when I do that, I'm going to get cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. And I'm going to go ahead and reduce or rewrite what I can. Cosine squared over cosine squared is going to give me 1, plus sine squared divided by cosine squared is actually tangent squared. If I think about my reciprocal identity, I can tell that it's going to be tangent squared. And then 1 over cosine squared, if I think about my reciprocal identities, will give me secant squared theta. And so this is my second Pythagorean identity.